All right. Hi, everyone. I'm excited to get back to workshops and talk to you today about monitoring distributed ML systems at massive scale with Apache Spark and Databricks. So this workshop timing is right after the Data Plus AI Summit run by Databricks. So I guess 2 weeks ago now. And yeah, hopefully kind of building on the energy, folks maybe really thinking about how their Databricks workflows work for ML and for AI. So, for those in the chat, feel free to share a little bit about yourself. If you've used kind of Spark or Databricks, if you're new to either of these two things, if you're new to WhyLabs and our products here, and we'll talk a little bit about all of those things today. Okay, so I'm gonna get started here. And just a quick introduction for myself. Again, feel free to give an introduction in the comments so that you guys can uh, it, just get some perspectives on the other folks in the room. I am a senior data scientist at WhyLabs and do all sorts of things related to the kind of machine learning and AI side of business. So I'll talk quite a bit about how our products are set up and what's more entailed. But the things that I work on are often about approximate statistics. So how do we take a massive amount of data and capture the right statistics for that data to kind of find the signal and the noise? Um, Real-time monitoring. So once you have those statistics and that metadata, we want to find trends in it. And so, how can we monitor some data that might be streaming in really, really frequently in real time and find trends in that data? So, coming up with machine learning models to monitor and to produce new metrics. And the way that we do this is all very data centric. So, we are spending a lot more time thinking about the data, the inputs and the outputs, and even intermediate data within your model process, more so than the model itself. So, there's some really cool things happening in the larger kind of data centric AI space. And then again, it takes ML and AI models to do some of these tasks, many of these tasks. So I work on those as well. Um, in addition to my work at WhyLabs, which complements it quite well, is my work at the University of Washington. So this presentation will be purely from the perspective of WhyLabs and not UW. But just to get some sense about me, so I work on evaluation metrics and synthetic data generation and ethical AI. So how do we think about the kind of societal implications of our AI systems? Okay, so I talked a little bit about this, the different parts that I touch on within WhyLabs, but these are the main components that I'm going to talk about today and that I work on. So, WhyLogs, where we do a lot of that approximate statistics, LangKit, where we're going to think specifically about metrics for generative models and text based models. And then once we have all of that approximate statistics for the with the right metrics, how can we combine them and monitor, do anomaly detection, all of that sort of stuff that we want to do to actually find insights within that data? Okay, so here's our agenda for today. We are going to start with the massive scale challenges in machine learning and AI. And then we're going to move on to comprehension challenges for generative AI and LLMs. So, how does this kind of go beyond that? And then finally, we're going to finish up with Apache Spark and Databricks. And this is meant to be a lot more kind of educational. I really want you to understand the fundamentals of all of these things. And then in between, I want to give best practices and tips so that we can think about how to improve our own systems, our own organization systems. and you may have your own tips and best practices that you've discovered. Please do share those in the comments. I want this to be lively, and it's not necessarily fun to talk in one direction, so please do comment in the chat. Okay. So let's start with the massive scale challenges in machine learning and AI. And I actually left quite a few of these off, but the first thing that may come to mind is actually not necessarily about data analysis, but if you've thought a bit about machine learning at scale or like streaming machine learning, there's a whole bunch of issues and differences between how you do machine learning and AI in a kind of streaming setting or at scale, right? So there are many machine learning models that just, especially pre kind of deep learning, that really took a lot more time if you have more scale. So it kind of grew exponentially. With your time or something above linear at least, and there are many other challenges with streaming machine learning models. So how do we evaluate it? How do we cluster data when we don't have all of our data all at once? All of these sorts of things. But I'm going to, and later we're going to discuss a little bit about how to use multiple machines to analyze data with Apache Sparks and Spark and Databricks, right? This is what this section's all about. But I'm going to talk a lot more about, at the beginning at least, about how to analyze a lot of data on a single machine, right? Because this is often a case, this is also often a setting that you're in as a data scientist. Or at least you want to get back to as a data scientist. And many of the issues that we're going to run into here will apply to the multiple machine case. So it's nice to start simple. Okay, so believe it or not, let me go here. So believe it or not, even though when you learn machine learning techniques, you may download a massive data set and do all of that processing on your machine or on a very large machine that you have in the cloud. When we get to any production environment, we often can't do that analysis in mass for the same way, especially for um, your training data set or any of these things are normally very large, especially when you're looking at production data, which dumps massive amounts of data every day. So let's think about some different approaches to analyzing data that doesn't fit all on one machine. Okay, so I'm going to offer three popular approaches, and we're going to talk through some of the pros and cons, and really kind of build some intuition for these different approaches and why we chose the one that we did at WhyLabs. So, one thing to keep in mind is kind of median and quantile calculation. So, um, some problems are easier than others. So, for example, there's algorithms to calculate a mean in a streaming way. So you can kind of keep track of the mean of a list of numbers. Even if you just iteratively add one more number, you don't have to like kind of go through all of the data and recalculate. That differs for other calculations that are really important for data science and important for the metrics that we use. So for example, a median, which is probably one of the easier concepts, it's really difficult to kind of approach this at scale. So a median, right, is if you lined up all of the numbers in order, can I find the centermost number, or often the average of the center two numbers, if there's an even number of data points. This is really hard to do at scale. So just something, maybe one task to keep in mind, although there's many more kind of advanced tasks that we're often doing as data scientists with respect to kind of evaluation metrics and that sort of stuff. Okay, so let's get on to our first approach. So this is random sampling. So if you have a ton of data that's coming in every day, and I say, okay, well, I can't store and analyze. Maybe I can store it, but I can't really analyze this data whenever I want to understand, what's happened, how my models change, how's the data changing. What I might choose to do is store a random sample. So in this little bit of code here, a 5% of our data, let's store that. So then we can put it on a machine. Maybe it still takes a big machine, but a single machine to calculate our averages and do our data exploration. So Our data might end up, if it was tabular data, might end up looking like something on the left here. So we have a smaller number of sampled rows than our total rows for the day. And we're just storing, those random rows. So these are just some lines in a CSV file that I had on my machine. I apologize here, but the pros and cons are that the data is in the same format as the original data. So this just looks like a CSV file as well. So this can be really easy for data scientists to use. We all know how to use CSV files, or in a database or that sort of thing. It's highly flexible. You can change the percentage of data that you've sampled. It works for batch or streaming data. So if you have batch data, if you have a large number of rows that you're processing, you can just choose a number of rows from that one file. But even if you're streaming, right? So every time some data streams in, you can randomly save 5% of it. And then it's mergeable. We'll talk about mergeability later. What are some cons? So some cons are really big when it comes to this sort of analysis that we want to do of our production systems. So often I don't just want to know the average or the mean of my data. I want to know what went wrong. And what went wrong is often related, not always, but often related to some outlier or some subset of your data, right? So maybe our system works really well, except for the case when this value is, high, or this value is missing, or so on and so forth. And that might happen only a small proportion of the time. Uh, So this is a problem. This is a conflict here because let's say the issue happens, this particular issue that I'm investigating happens on 2% of our data, and we're storing 5% of our data randomly. There is, depending on the volume of data, there's some chance that we get some examples, but we might not get a very representative picture of this phenomenon, especially because it is, an outlier. It's a small percentage. And the precision of the measurements that we make is also going to be really dependent on kind of what percentage of our data had this problem. And it has some of the same storage issues that your production data has. So how do we store this thing? How, do we spin up a database? Do we keep a bunch of kind of blob storage for files? All those sorts of issues. Um, and so, yeah, the simple random sampling can make it really hard to capture those rare events. And we actually did some experiments at WhyLabs a while back, looking at different distributions of data and comparing profiling data, which we'll talk about in a bit, versus data sampling that I'm describing here. What you can see is that the relative error, sometimes it depends somewhat on the distribution of data, but certainly depends on the metric. So right now we're looking at the 95th quantile here, and we're seeing the relative error. So if I took data here, so looks like 10,000 records. If I took 10,000 records of data and I use the sampling technique versus the profiling technique, this is the relative error between the two. So 0 ideally means that we won't have any issue. We can perfectly capture the metric. And then some error would show that we're not perfectly capturing this. So you can see already that the profiling technique has much less error for these distributions. Okay, we can dig into that for a session on its own, but let's not do that. So we'll go on to the second one, static data profiling. So profiling, I'll talk about in a little bit, but if you use like a pandas.describe on a data frame, you might get a profile. So these are things like um, it might give you the mean, it may give you the standard deviation or some different metrics, maybe the most common values, maybe something like missing values, that sort of thing. So data profiles or data profiling is the act of reviewing and analyzing a data set, often programmatically, to understand the structure and information. And so a data profile, which you might produce, is this sort of thing like this. So it might be stats about the data that you've just seen and analyzed. And here we have some stats. If you had performance data, we can also include data or performance metrics in those profiles. So what are some pros of data profiling as far as implementing this on our production system, so that we can kind of keep um, data for analysis if there are future issues? So, one is fast access to key metrics. So, right, instead of downloading all of the data from yesterday's run and calculating, standard deviation or some specific metric that you care about in your organization, if you have data profiles, this is going to be calculated. You've already calculated this, and this is as easy as retrieving this from our file for the day. Very, very easy. Uh, because you're just calculating a bunch of metrics, and at this point it's very condensed, you have very low storage size. Um, and this last point is a little more nuanced. We'll talk about it in a bit. But these are kind of these are not estimates. These are true metrics on each batch of data. So that error that we saw earlier could be as low as 0 in lots of cases. But there's some big cons, and we'll talk about those. So the cons are that this really only works for when you're thinking about a production system, for a system that works on a single machine and for analyzing a specific time window size. So, um, first thinking about the different metrics. So there's also problems with kind of root causing a system where you want to ask kind of these, common questions that are really difficult to do in a static data profiling approach. So, for example, if I wanted to know how does this new metric, I've come up with a new metric, how does this apply on private data? Well, because I didn't calculate that back in the past when I had the full data, I'd have to go and do that analysis again if I've even stored the data. Um, Relative ranking across like wider scales of data. So looking at new time windows. This data doesn't combine very easily. And we'll talk a little bit about that mergeability and so on. So this kind of ability to take one batch of data and combine it with another batch of data works well for when we have individual rows, maybe our random sample, but does not work well for the static data profiling. And this is where this third technique comes in, the dynamic or sketch-based data profiling. And this is what we use at WhyLabs. So you can use our open source, and it's easy as calling y.log on a data frame, and we'll capture this sketch-based data profiles. So why do you want that? So this gives us more information than just kind of a fixed number of metrics, although sometimes what you'll see is the metrics themselves. We're actually capturing a very specific type of sample of the data so that we can recreate a histogram of the data. And this histogram has error bounds. It can be kind of examined at very, very tiny uh, points of the histogram. Of course, um, determining how tiny that point is might tell you we might have a certain amount of error on that. And so it has many of the pros of both data profiling the simple way and of sampling. Okay, and so the a open source tool that we released several years ago now for doing this is called WhyLogs, and so this is for logging your machine learning data using this sketch-based approach. It's open source. You're welcome to go and check it out. We'll see it a little bit later today. Okay. And so now that we have YLogs, so this package, which I want to emphasize is really capturing statistics about your data. So one thing that's really nice about statistics about your data is that it's not the raw data. So I sample some metrics, but I don't sample like I don't hold the whole data at any point, any row of data. Um, so what happens here is now I can not only use these metrics, these profiles to summarize this data, combine it, do analysis on that data, because this really represents the signal in that data without needing the actual raw data. I can also take advantage of the privacy preserving effects. So if I do just have distributions and have the shape of the data, I can pass that in to a third party like WhyLabs to combine, to visualize, to do all sorts of things in a way that's really privacy preserving and again scales at kind of production scale. And this is really, really, really highly scalable. So terabytes of data or more. This works really well because we are taking this metadata and these high level statistics and not each individual row of data, unless you choose to. And we'll talk a little bit about that. Um, so then what can we do? So we can take the data from different locations. And because the data sketches approach works for streaming data because it's mergeable, we can pass in things from a stream or from batch data or from your training data, all sorts of different locations, feature stores, that sort of thing. We can capture all of these statistics inside of YLogs, and we can pass this along to look at these trends over time, calculate aggregate statistics, visualize, and then add machine learning models on top of that to monitor and forecast. And then from there, we can get things like triggers and alerts and so on. I have a question, which is a great question. Can't we use the sketches to help us sample more efficiently? And the answer is yes, absolutely. So that is one really cool thing about this is so in addition to just capturing these high level statistics and metadata that is most typical for YLogs, um, if you want to store some sample of your data, we can now look at the distributions that we've been collecting of our data and determine, well, which of these rows are more interesting so that we don't sample, a bunch of the very typical rows. We instead sample maybe some subset of the typical rows, but really focus on those out of distribution or outlier rows. So yes, absolutely, this is the real benefit of having these sorts of distributional approach to understanding our data in real time. All right, so let's now step beyond YLogs, so beyond the data sketching side of things, and think about how this applies to generative AI and LLMs. So um, this is really great for, what we said before is really great for tabular data, even categorical data, this sort of thing. We have all sorts of kind of sketches to look at those sorts of things. But this becomes different when we think about complex text and LLM data. So why is this? So let's say we had a LLM application here. So we have an application that's built around an LLM. And a customer asks a question, or we ask a question on the customer's behalf, and we get a response from the LLM. And this is an example of a response from an LLM. Um, Having the text itself maybe isn't that interesting. In some cases, it might be, and so we'll talk about capturing a trace. But what's really um, hard about text is that we want some text-specific understanding, some semantic understanding about the text. And there's a long line of history of natural language processing and computational linguistics where we start to think about, well, what is this text made of? What is it? What's the semantics? What's the syntax? And so there's lots of different metrics here. So for those looking at this, if you're familiar with NLP, this task right here is entity recognition or named entity recognition. And so in this example, for this sentence, what we might find interesting is actually how many named entities are in this text. So named entities are often kind of proper nouns, dates, organizations, that sort of thing, right? So this response from an LLM gives a date, December 1903, gives a organization, gives many different people, and gives the Nobel Prize in physics, right? A proper kind of thing or work of art, as said here. And so, why is this important? Well, this actually might tell us a lot about how our application is working, depending on what we want it to do. So, for example, we know that LLMs have often have problems with hallucinations and that sort of thing. And so, if you made an LLM application where, for example, a user is kind of asking specific facts about the world, maybe that's just the context. This is for maybe college students or high school students to ask questions side by side while they work or something like this. It will be important for us to understand, well, of the responses that we give, how much of them are like containing proper nouns, proper dates and things like this. This is a very kind of factual response. This is very different from something that maybe you don't expect so many facts, right? Like this is a general advice sort of application or something like this, or producing newsletters for customers or something like this. In that case, we would be probably pretty worried that our responses, if they start having metrics like this, if they start saying, "Oh, well, there's let's see what's here. There are six of these named entities in a sentence of the response." This is saying that this is really full of potential hallucinations and lots of facts, and that may not even match our expectations of the application. So knowing how that trends over time, doing some sort of alerting, doing some sort of um, kind of maybe blocking even of these responses are important. And it all really depends on these sort of semantic metrics, like the number of named entities or the sentiment or that sort of thing. Another challenge, and some of these are specific to LLMs and kind of have arise from LLMs. So relatedly, are hallucinations. So if you aren't familiar with hallucinations, I always think this is a fun one. This is a prompt at the top asking to summarize an article and passing over a URL. And that URL, importantly, does not point to a real web page. That web page is completely made up. This does not exist, right? But the LLM, seeing that URL, seeing those bits of words inside of that URL, ChatGPT prompts to avoid content filters, can hallucinate a whole description of an article just from that. That and the fact maybe that it's New York Times, that sort of thing. And so that can be really concerning. And we need metrics to understand this, right? Like tables of statistics about the number of letters isn't going to really help us. We need kind of another layer to create metrics to understand it. The last thing to think about before we get here on the solution is that the data that's coming in for an LLM is much more complicated, right? It's a combination of prompts and responses, often conversations. So there's some historical context. All of this stuff has to be thought about for this. Um, and so this kind of text and LLM specific tools, often generating metrics and calculating metrics that relate to text and that give us important information about the named entities or the complexity, that sort of thing. This is combined in our open source LangKit. So LangKit is really all about a layer on top to add these metrics related to text and LLMs. Um, right. And so then this allows us to translate this into some really helpful questions about quality, sentiment, security, governance. Here's some of the types of questions. Are my responses and prompts readable and accurate to their designed intent? Are there jailbreak attempts, which is kind of a user asking a question in a way to thwart maybe the expected use of the LLM? um, Security questions. There's so many security issues that come up in the language context. um, Here's some examples of the metrics. So I've mentioned a few of these, but readability score, right? Like so, or grade score and complexity scores. Is this language that's at like a fourth grade level, which is good for like general applications? You wouldn't want something that's always at a college level of text. This may not be really helpful for your customer service application or something like this. The relevance of your text, right? So, does your LLM give responses that seem pretty unrelated to the prompts that were asked? Or differently, do the responses or prompts are they very related to user-defined themes or themes defined by us at WhyLabs here that might be worth flagging? So, for example, Maybe we don't want to give legal advice, and we'd be really concerned if we see a lot of responses from our LLM that look like legal advice. Um, and then again, for security and privacy, things like patterns in our data. So, do we see social security numbers or phone numbers or any other PII inside of the data? Do we see these prompt injections or jailbreaks? Do we see refusals? So, if you use an LLM, often you'll see, the LLM response of, "Sorry, we can't answer this right now." We want to make sure that we don't we want to make sure that we can capture these refusals, because maybe we want to do something with those and make sure that they're not being shared with a customer. And then, toxicity, swear words, or kind of really hurtful things, or sentiment. So these are the sorts of metrics that LangKit brings, and this allows us to now calculate these metrics with LangKit, and now we have a table of data which looks a lot more like what we saw on the WhyLabs side of thing. So now we can use our data profiling techniques on top of all of these metrics to again capture these statistical summaries of the metrics, so that we can understand how these trends happen over time. Okay. Cool. So I'm stopped here. I saw a question, and this is a perfect time. So, does LangKit measure response confidence? Um, Yes. There have been several recent papers about how the model's confidence expressed can often be overblown, fooling users. We have many metrics related to hallucinations. I think, which gets to this sort of idea of response confidence, right? Like this overly confident response that may be inaccurate. Um, I think we have also things that are related, or things like sentiment. So, how strongly positive or negative this is. We don't necessarily have a metrics that's specifically confidence. I think that's really interesting. It would be measured probably in a similar way to sentiment. So, sentiment is about, very positive words or really negative words. Often we think about a review. But yeah, you can imagine something like confidence in the response, like how convincing is a response, and seeing trends of that over time, because you may worry about hallucinations, especially if you have very strongly confident responses in certain areas, or topics. Yeah. So great question. Things related to confidence, especially hallucinations, which I think most people are worried about when they're thinking about response confidence, but not necessarily confidence itself. I think that's an interesting one to explore on our end. Okay. So, how does our organization take actionable steps with this data? So now we have these data profiles, and we've, perhaps if we're using text, we're doing all of these interesting metrics on top, that we're profiling. But then, how do we actually use this data? Well, one is the kind of broader WhyLabs AI control platform. So this is really, so the two solutions that we talked about before, WhyLogs and LangKit, are open source tools to really find some signal inside of the massive amount of data that you may have passing through your application. Now the question is what do we do with it? How do we, you know, actionably create insights on this? And the answer can be a number of things. So the first one on the left here is observe. We want to see trends over time. We want to do some monitoring of these metrics to make sure that, hey, are these metrics don't change much from our training data? Because if this deviates a lot from our training data, this might tell us that we need to update our training data. Or if we have the model performance, if we have some labels for a model, which isn't always the case, but when we do, we can look at that directly, right? We can look at model performance day over day, and send an alert to the team when model performance goes low. And that might not just be for the overall model. We care about like little subsets of the model, right? This is important. So drift, model performance, data quality. So there might be duplicates in your data or something like this just from your system itself, as well as different use of your system, right? So customers may be using the system differently, so this can trigger data quality things that we want to understand, and so on. So this is really about kind of observing these trends that we see over time from the statistical data. And then the second one was really necessitated from the LLM use cases first. And this is the secure side of things. So now, actually, let me show some slides here. But the secure side of things is really about preventing in real time issues that might come up in individual calls. So, for example, maybe we do see that a user provides an adversarial prompt, something to try to get some private information or break the LLM. We'd like to block that interaction. Or we might see that the LLM gives kind of a bad response. We'd love to see that and then kind of inject a better response before we even respond to the customer in in their chat window or something like this. All of these sorts of things. This is more on the individual. We want to trace and debug and find individual instances of issues as opposed to these higher level statistical descriptions of our model performance. Okay, so I apologize. I'm probably going to repeat a bit of that on the slides here, but with with WhyLabs AI Control Center, when you pass in those data profiles, which again is summary information, not the full data, we can now centralize all your organization summaries, and you can visualize those summaries and understand what data is being collected, which is very important in the context of Databricks and Spark, where we're having multiple machines do these calculations. We can discover trends over time. We can monitor for issues and send alerts, and we can investigate individual traces and many more things. Okay, finally, let's get to the using Apache Spark and Databricks side of things. So now we talked all about this kind of how do we think about these things at scale? What are some of the issues about production systems at scale? And how do we monitor? Well, how does this extend to Apache Spark and Databricks? Um, I won't have a lot of time to go over Apache Spark fundamentals. There's a great presentation, a bit of an older one, but unified big data processing with Apache Spark. You could search for that and look through that presentation. I'll give you some high points from that presentation now. So, for those of you who have learned of MapReduce, so MapReduce is really kind of the beginning of the computer science community's kind of explorations of processing, massive amounts of data. So data at scale, doing this sort of data analysis. So in MapReduce, we kind of have some database of data. We want to read in that database of data and into different kind of queries here we see, and then do some calculation. And so we map some calculation onto these different subsets of the data, and then we're going to bring this back together and reduce it and get some response. So the problem with MapReduce, as defined then, is it really takes a lot of data replication because we're taking that data and we're sending it to different machines, different nodes to do this calculation. And then we have to take it all and write it back onto disk so we can understand it. And what we would like is to kind of the same problem that we had with our single machine. We'd like to be able to use RAM for this. So now if we can do this in memory, this becomes much, much easier for us. And this is basically that same thing, but instead of passing to disk, we're now passing to memory. And the benefit of this and this is what Spark does for us. So Spark allows us to, instead of sending our data with many disk reads and writes, it allows us to both do this processing in memory, but then also combine all of these different actions, so transformations and actions, and then do all of those actually in a lazily executed way, but we won't talk much about that, and then writing that later. So this really reduces the amount of I/O. It's so much faster than MapReduce, and it allows us to do a lot of processing on a lot of data, as we often need to do as data scientists. Oops. Okay, there are a number of libraries built on Spark. So Spark SQL, so Spark Core is the more important part. This is actually, I will share really quickly. So this is actually kind of the bulk of what we think about for Spark. This is taking our data, splitting it up into different nodes, and doing the actual work, executing these jobs. There are many other parts that I won't talk about because it's not as relevant here. But I do think it's worth noting that both streaming and Spark go together really well. So this idea of actually building on that same mergeability that I talk about for WhyLabs, this mergeability allows you to stream. And so Spark streaming also relies on the same kind of principle of, well, when we have massive amounts of data in a production system, what we're going to be doing instead of just dumping a large amount of data and doing some processing is we're often going to be adding data over time, and we'd like to do that processing on the little bit we've added and combine, as opposed to having to reprocess everything all in bulk. um, and so Spark, the fact that Spark is aligned in that way is great. MLlib is just a reminder here that machine learning can happen on Spark as well. And so this also takes this sort of streaming approach with very different algorithms in some cases, but also a thing that's done. Okay. And maybe before I get to this one here, apologies. So I think right here. So here is maybe one picture just to help a little bit with this visualization. So we have our data, and we're mapping onto our Spark RDD, and we can do a process here. Actually, this isn't the more detailed one, so I'll leave this alone. And then we capture statistics. Okay, let's go back here. And here. So on top of Spark is Databricks, which combines more than just Spark, but Spark with many other services. So some database, some other tools, often things like ML Flow, to create a nice workplace that you're able to um, run Spark on data in a very easy to use way and system. And we'll see Databricks in just a second right now. But these things are combined. All right. Okay. So let's go ahead and look at our demo here. And so I'm not passing out this code, and you don't actually have to use Databricks. In fact, let me pull that up just to show you another approach to this. So inside the WhyLabs documentation here, we can see some description. Actually, I think this is one of the more helpful pictures, but I didn't have a chance to redraw it and make it beautiful. So what we're doing is we have all of our data, and we're partitioning that data. And if we're using this in the WhyLogs context or the WhyLabs context, what we want to do is then apply LangKit and then profile our data. And we're going to profile that data in the separate partitions. And then because the profiles are mergeable, thanks to the sketch-based profiling, we can then merge them all together very easily and in a way that captures error bounds and things like this accurately. And so this is how this works in the WhyLabs kind of environment using a tool like Spark. And so from there, we have our global profile, which has all of the data from these subsets merged together. And this profile is what gets passed on to be combined and used over time for analysis and things like this. If you want to see the code for how to do this, I think it's probably better to look at it here before we get into the Databricks setup here. But you can see all you really need to do is import WhyLogs with the extra for Spark. So there's a couple of functions that we need to use for Spark that are different from WhyLogs on a single machine. And then here's the code that we need here. So we need to be able to create a Spark session, Spark files, and then our WhyLogs function here, collect dataset profile view. So For those of you who are new to Spark, totally okay. We're doing this in PySpark, by the way. So this is Python code. Um, so we're going to create a Spark session and give it a name. And we have a getter create here. So if it's kind of global. And then we're going to use Apache Arrow. You don't have to use Apache Arrow, but this makes it even faster to deal with our data, the storage of our data. So this is great. We'll give a key for this, and then we'll set that key to true. And then all we need to do is download our data here. So we're pulling the wine quality data set from the infamous UCI ML dataset repository. Not infamous, famous. Nothing bad happened. And then we're going to add that file into our Spark context. So after we've done this, we're going to create a Spark data frame. So we can take our data, and depending on how it's formatted here, we have some settings for that. And inferring our schema, we can take this data set and create a Spark data frame from this. So for those of you who have used Python, data frames, or R, actually R, the original, but data frames are a way that we think about our data, kind of structured table form. There in PySpark, there's Spark data frames, actually, and Scala Spark as well. But there are Spark data frames that are a little bit different. So these are RDDs. It is a little bit different, but as far as our concerned, we're going to put this in a Spark data frame. And then all we have to do is call this function, so collect dataset profile view, using this Spark data frame. And because of Spark and the way it works, because it's lazily executed, this means that this function is going to, only at the time that we've run this, take the data, separate it out. Well, actually, we separated it out when we've added our data to the Spark context. But for all of the different partitions of our data, we're going to profile that data and we're going to merge it back together to retrieve a data set profile view. And that's it. So for those of you who've used Spark, maybe these things you kind of think of boilerplate, but it is very, very simple. It's effectively this line after you've gotten your data in. And there are many different methods that you may use for things like segmented data. So I haven't talked about segments in WhyLabs, but effectively, if we want to explore some of these summary statistics for certain subsets of our data, we can create segments, and then we have a different method to do that here. And then we can inspect our profiles the same way that we would with a normal profile in WhyLogs. So we can just take our profile view and look at it in pandas, and so on and so forth. So that's that. I will check for any questions here, but then we'll maybe move on just to see a little bit about Databricks. Again, I don't expect you to have access to this. There is often free kind of trials of using Databricks, but I didn't want to have to organize this here. So this is more of a demo, you watching as opposed to following along, unless you have Databricks and want to see this. But Databricks really, as I said, is kind of a wrapper on many different tools that you can use. So a large part of this being Apache Spark, part of this being different database systems. It actually depends on which version of Databricks you use. So we'll leave that alone there. There's also tools like MLflow or different tools to help us create kind of a DAG of different jobs that we want to do in order. But the cool thing about Databricks is that they are very oriented toward a Jupyter notebook sort of setup here. So I can create a new notebook. And just like we've done as a data scientist in the past, we can do all of these sorts of things. So I might do something like import. Actually, I probably have to pip install here. Pip install WhyLogs. I just want WhyLogs, I think I do. Oops. No, I want a new one. Let's create a new resource here. La la la. So we'll use 4 cores. Cool. Sorry, and I should have gotten this started before, but we can install WhyLogs and then just run the lines of code that I just showed. But now we don't have to, we can use many more cores and many more machines in the Databricks environment. So this is going to take a little bit of time. We'll come back to this, but really walking through these lines of code, very, very simple. And allows us to do the same things that you would do with WhyLogs, but at scale, at Spark scale, which is really great. I will let this run, and we can maybe look at this demo after, but I think now is a great time to break for questions. So if folks have questions, please do write them in the chat. I'd love to talk about them. All right, I have say more about segments. Yes, happy to talk more about segments. So let's see if I have some nice slides or something to point to here. I just have API things, which maybe aren't that interesting. So, so I guess what I'll say about segments is that at a high level, um, we want to sometimes be more specific about how we want to separate out our data. So because YLogs and because a lot of this sort of profiling approach is really about taking all of our data in a batch. So a batch is often some time window, maybe for a day for a particular machine that we're running our model on, or 5-minute time window. Just depends on your context here. We normally just summarize over the data for that time window. And segments really allow us to define different kind of ways of splitting our data that we know we're going to regularly analyze for. So for example, if this is a retailer, we may want to segment on which region of the world we're selling on, or which product category we're selling on, because we may have separate models or make different decisions or have different responsibilities for interacting with those. And so the segments, what it does is it really just creates a different data profile for the different segments of data. And then we merge them together to do analysis sometimes, and sometimes we leave them apart to do analysis. I see another question, maybe more detailed. So can the dimensions for segments come from the profiling? Great question, and absolutely. So so you can define the segments by just saying unique, every unique value in this particular column should be its own segment. Or you can look at the distribution of the data and say, I'd like, the 10 most appropriate segments for this data, right? I think defining segments is a little bit manual if you start to go in that process, just writing kind of your functionality. But the fact that segments are database can be defined based on the data that's being passed in. It doesn't have to be fully predefined. Yeah, let me share maybe quickly segments, segmentation. So so lots of things on segmenting data. But so manual segmentation here, where I might define these are the columns that I want to segment my data on. This is how to do it in PySpark. And then automatic segmentation here, this is this idea of I want to take some training data, for example, and calculate what I think my segments should be using this algorithm. So this is one place to kind of define these segments there. And this means like maybe I don't even know which columns to segment on. If you want to just segment based on value, you can just use what's in here called the manual segmentation for specific columns, and then those column values can be defined by like unique values by default or more complex ways. Cool. Hopefully that answers it. If not, love questions, so keep them coming. Now let's see if we're still importing. So yeah, we'll probably not be able to get a view of this in Databricks, which is, I apologize, my fault. I should have preloaded this, but I think that's okay. Cool. If there aren't any questions, I will be happy to, well, let's go to my last slide here, share my contact info. So you can reach out to me at bernice@whylabs.ai. And I'm on social media in general, just at Bernice. So on LinkedIn, on Twitter, and on all of those sorts of things. If you have WhyLabs questions, our Slack group is very easy to join. Come to Slack and ask away. And yeah, thank you so much for joining. I will. I'm excited for the next workshop. I'm excited for folks to use the Spark side of these things. We have many customers using this, but hopefully after the data and AI, more people are thinking about Spark and combining that with their monitoring. Cool. Have a good day.